All right, everybody, welcome to the video here for lesson number 5's homework assignment. So in lesson number 5, we learned how to factor and use these some solutions as complex solutions. So let's just jump right into it here. So for number 1, I see x to the 4th minus 1. What I'm thinking there is difference of two squares. Both x to the 4th and 1 are perfect squares. So when I first start factoring out, I'm going to get x squared plus 1 and x squared minus 1. And an x squared minus 1 is also factorable over the real numbers. X squared plus 1 is factorable over the complex numbers, but I'm just going to leave it. I know at the beginning of the lesson we showed that they are factorable, but then towards the end we said there's kind of an easier way of solving these. So essentially, if you factor this expression over all the real numbers, you then can set each piece equal to 0, including this x squared plus 1. So these last two are easy. I'll do those first. This last one, if I subtract 1, I get x squared equals negative 1. Square root both sides, I get x equals plus or minus the square root of negative 1. But we know, since we're really good at complex numbers now, that gives us x equals plus or minus I. So your solution set for number 1 would be negative 1, positive 1, and 0 plus or minus I if I put it in a plus bi form. For the second one, I see 4 terms, so the first thing I think of is grouping. I'll change colors here in case we get close to what I did there in purple. So if I group the first two together, I have x squared as my GCF. If I group the last two together, I get 25 as my GCF. And then if I put that all together, I'm going to get an x squared plus 25 and an x minus 3. Nothing else is factorable over the real numbers, so we'll stop factoring at this point and set everything equal to 0. So if I subtract 25 here, I get x squared equals negative 25. Square root that. I get x equals plus or minus the square root of negative 25. Now we know the square root of 25 is 5, so negative 25 would be 5i. So my solution set here would be 3, 0 plus or minus 5i. For the last one, it's kind of factored already, but I can't factor it anymore because I would have to use a complex number to factor each of those. So just set each part equal to 0. So I'm going to get x squared equals negative 4, so x equals plus or minus 2i. Right, I'm skipping a couple steps there, but I'm hoping you get the concept at this point. I would get x squared equals negative 16, so x equals plus or minus 4i. Right, square root of 16 is 4. So then the solution set here would be 0 plus or minus 2i and 0 plus or minus 4i, again, if I put it in a plus bi form. Number 4 wants us to state all of the zeros of p of x. Now, some of these are real, so you can get them in the calculator, but some of them are not real. There should be 4 zeros, right? 4 total solutions. So we want to start by trying to factor this. So to factor this, I'm trying to figure out what multiplies to make negative 27, but adds to make positive 6. And that answer is going to be positive 9, negative 3. So I'm going to get 0 equals x squared plus 9 and x squared minus 3. Neither of those is factorable using the real numbers, or the second one's factorable using radicals or square roots. I don't want to do that. I want to just go right to solving. So I can say x squared plus 9 equals 0. Do your subtracting 9. X squared equals negative 9. So x equals plus or minus 3i, right? Square root of negative 9 is 3i. For the other one, even though this is a real answer, it's an irrational answer, because when I move the 3 to the other side, I'm going to take the square root of 3. So I'm going to get plus or minus the square root of 3. That's real, just irrational. It wouldn't come up in the calculator, actually. So then your answer here would be x equals negative square root of 3, positive square root of 3, and 0 plus or minus 3i. So talking about number 2 here for a minute, if I was to graph p of x, if I was to graph number 2's equation, it would only intersect the x-axis twice because it has 2 real solutions and 2 non-real solutions, 2 complex solutions. Number 3 says find the solutions to x squared minus 6x plus 10 equals 0 and use these solutions to write this as a product of linear factors. So it tells us the equation, but that's not factorable. There's nothing that multiplies to 10 that would add up to negative 6. So we have to jump right into the quadratic formula here, right? So I have x equals 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 10, all divided by 2 times 1, which is 2. When doing the quadratic formula, remember you want to figure out what this discriminant number is, right? Negative 6 squared minus 4 times 1 times 10. That gives us, what's that going to give us? Negative 4. And then the square root of negative 4, well, that's just going to be 2i. Right, so that's all my kind of like side work. So when I go through and try and finish this, remember I separate into 2 fractions. And then I simplify. So here's my 2 solutions. Now, if I know solutions, that means I can find the factors. So if I take each solution and I solve and make it equal to 0, by setting it equal to 0, I'm creating factors, right? If something's equal to 0, it's a factor. So that means this equation, x squared minus 6x plus 10, can be shown as a product of 2 linear factors of x minus 3 minus 1 and x minus 3 plus 1i. Right, so I have x minus 3 minus I and x minus 3 plus I. Right? Weird looking factors, but they are factors of this polynomial. The reason why is this graph won't touch the x-axis, so there's no real solutions. So there's not going to be real factors. Hopefully that made sense and you were able to do a lot of that on your own, and I will see you soon.